weird.
Oh, not a big deal.
Oh, I thought it was.
Because, I mean, if you just take math out of sequence, some people do that.
Join. Notes. Yeah, I know. You're sharing those rest of you. And also, how do you open that assignment? I don't get bored.
Yeah.
I don't know. This also didn't have to put it on. At first we couldn't turn it in either. What? At first we couldn't turn it in or over there. So that's why I didn't get done. So I didn't know what was going on. Well, I saw it going on.
Hey, somebody want to erase the board for me? That'd be great. Here.
Yeah, Jonas got it. Stars got it.
Stars got it.
Take it.
There you go.
Thank you.
Perfect. Thank you.
Wait, do it? Nick, listening to the rap, it's catchy. What? The rap. Okay, you gotta do the whole 5th period with rap. No, I'm gonna write rhymes in 5th period. Okay. I'm writing one for Sherwood called Marinara Sauce. I know, it's kind of sad. But you know what? Really, better be good. If you're good at it, you gotta keep doing it. Just like I'm
Goes for lots of different things.
I'm awake today.
I see that all the time.
I fell asleep at like I slept until 7:30.
Star, you missed a spot.
Yeah.
I'm dead serious. There's a spot right there. Yeah.
Okay.
Thank you, John. I appreciate the help.
Okay, hey, welcome back. All right, today. Okay, again, yesterday's video, sorry the sound went out yesterday because I figured out that, because of the new microphone, I just got it, when I turn on the projector to show you the scene chart, when you switch projector, it turns off the microphone. So that's a weird quirk. I figured that out yesterday. So I know. It was the first day. It's working today. It's working beautifully, so because I'm not using the projector, so it's fine. I'm glad I figured that out after your guys' class because I noticed it wasn't working. It was just when I flip the projector on, it turns off instantly. So good to know. Little quirk, we'll figure it out. Question?
I get nervous to ask questions because I don't like hearing my voice when I'm recording.
You'll be fine.
I thought
No one's gonna know it's
I had a
you.
question yesterday, but I didn't ask it because I'm recording.
Come on.
Just watch the videos.
I'm B-Bucks.
No, don't be back. Ask it anyways. No one knows it's you.
Yeah, my voice gets really, really high on things.
Oh my goodness.
Yeah.
All right. I have to hear my voice, and I have to put my picture out there for the world to see, because it's on YouTube. So it's even worse. People can just be like, oh, look at that. He's a dork.
There's only 2
Don't care.
lines, so fine.
Okay. Now, hey, here's what we're going to do today. We are going to continue on. I'm going to do a couple examples of the laws of exponents to make sure that you understand exactly what type of homework problems you're going to be getting today. Because, yes, I said you are getting homework today. And then I'll turn you loose and you can work on that. Okay? I believe we're all here today. That's nice. Kind of a rarity. I don't have everyone here all the time. Okay. Nice. Good. Okay. We have just a few examples. I want to talk about the product rule, quotient rule today for sure, to make sure that we're comfortable with that. I want to talk about how to do it when we have negative exponents, because I know I hinted at that yesterday. I kind of showed you where negatives come from, but we never went through an example of that, so I want to make sure that we get to see at least 1 or 2 in case when you're comfortable with that. And then we got to talk about scientific notation today. Like, what's the purpose? Why do you need it? That's what we'll talk about today, because it will happen. You will have a lot of couple problems, so we'll try to do a few of them. Okay, I'll try to do 1 or 2 of the different types you'll see. Okay, so a lot of today is just examples. Something that if you're not quite getting something, you want to see a certain example, a certain type, throw it out there. Don't be afraid to get picked up by the microphone. So throw an example out there, okay? All right. So here we go. We're on section P.2. This is the last day of P2. We will move on to P3 tomorrow. Remember, after the fourth section, that's like next week probably, we will take a quiz on this stuff. Quiz you can always retake, so don't be afraid. It's just, you'll have a practice test. You can see kind of what it's going to look like. I'll probably get you one of those. Maybe later this week I'll give you a practice test so you can kind of get a feel for what the first quiz will look like. Okay, and we'll go through that. We always take a day or 2 to review that. Okay? All right, but P2, we're on the laws of exponents. so the first thing we need to do, we need to cover those basic laws. I want to make sure that we cover the product rule. Give you one or two examples of that. I want to do the quotient rule. Now, with the quotient rule, that's just the one where you simplify. Top and bottom, they have things in common, cross them out, whatever you need to do. Then, we'll eventually move into... Is that me? Or is that that?
That was done. I think.
Alright, that was weird. Alright.
That's intruder right there, man.
Okay.
Tell it.
Alright, powers of power rule, or powers rule. We'll talk about that. And then eventually today, our main goal here, and I'm going to put a star next to it, we need to talk about negative exponents. I want to make sure you're comfortable with that. How to work them, how to use them, what's the shortcuts. Okay? Because we talked about the real math gamma tomorrow, but this is just weird today. Okay.
I'm scared.
All right.
Just go home.
Alright.
That's not Jan.
We'll just go. Alright. And scientific notation. Okay, so does everyone understand what we're going to be doing here today? And then eventually we do have homework. Homework I'm going to make it due Thursday this week. I may push the date back until Friday. But it's tentatively due Thursday. We'll see kind of how hard it is, how long it's going to take you.
And a lot of us are gone tomorrow.
Yeah, no, that's why I don't like that. So we'll see. I'll make the call tomorrow, whether we're going to push back to Friday or not. So we'll see. So, because I want to give you some time. Maybe the egg is I'll make it. Okay. All right. Any questions? Okay, remember, don't be afraid to ask questions in case you're not getting something. You're like, God, I don't know what you're doing. You're fine. You can't. They don't see you. Sees me. Okay. All right. So. Okay, let's first talk about the first example here. I just want to do just a simple product rule, something like 3x squared y times 11x y to the 4th z to the 15th. Okay, basic product rule, something where you just multiply things together. Now, if you're that person that doesn't remember the rule, like, God, is it adding, is it multiplying, I don't remember, that's where you can expand it. You can always expand it out and then write it down later and just rearrange. How I always think of this is you're just multiplying. Normal multiplication, what I mean by that, 3 and 11. Those are the numbers you're multiplying. It's product, right? Because that's what parentheses mean, you're multiplying. The letters, just throw them in the back. You don't need the letters. Throw them out back. That's how I think of it. So, 3 times 11, what do you get? 33, okay? And now, if we just throw all the letters in the back, we can combine them later. You know, if I want to just throw that x in the back, the y back here, if I want to throw those x, y to the 4th, z to the 15th, that's fine. You can throw them in the back. That's fine. Just dump them back there. Because really the whole point was to take the 3 times the 11. That was the whole goal. Now, once all the letters are back there, now you can start combining them. Because this looks goofy that you have a bunch of variables everywhere. So, like, how many x's are here? Yeah, there's 3 x's, right? That's a 1, that's a 2. So there's 3 x's. That's x to the 3rd. Y's, there's what? 5 of them. There's 1 and a 4, so there's 5 y's altogether. And there's 15 z's. This is the answer. That's what I'm looking for. Again, if you're like, God, how do you know it's adding? Just write out what this means. There's like 2 x's sitting there. It's x and x, and there's another x. So that's 3 x's. That's how I'm getting that. So, okay, any questions? Okay, all right, seems pretty confident on that. All right, let's do a quotient rule. Let's do one where you have to like simplify some stuff. So, let's go with 4x to the 2nd, y to the 3rd, z over, let's go with 18x, y to the 10th, z to the 3rd. This is a quotient rule. We have things top and bottom of a fraction. We need to simplify it. So the first thing that you need to realize is for fraction, you just deal with the numbers first. So if the numbers can be divided like all the way out, that's fine, you just divide it. If you know they can't, can 4 go into 18? No. So what you do at this point is just, what do they have in common? What, a 2? Divide the 2 out. That's what I would do. So What's 4 divided by 2? Okay. What's 18 divided by 2?
9.
Alright, there you go. There's your numbers. You took care of the numbers. They're good. They'll stay there from now on. And now for the letters, now you just cross them out. You start canceling things. So, and you have to worry about numbers. So there's 1x there and there's a 1z here. So now we'll start canceling. So what I always think of is like where the most of the letters are, that's where they'll stay. So like for instance, I know like comparing the x's, there's more x's on the top, that's where they'll be in the end. There's more y's on the bottom, that's where they'll be in the end, and there's more z's on the bottom, so that's where they'll be on the end. But you just cross them out. So like, for instance, I'll take away 1x here, so I take away 1 from the top, leaving me with 1x. So there's 1x left up there, and I'll write it down right away. When you cross them out, write down that answer right away so you don't lose track of what x's you have left. That's painful watching people like do all the correct math and then they leave all the letters off in the end and get all their own answers because they lose track of what's left. Okay, y, so take away 3 from the top, take away 3 from the bottom, so 7, write that down, there's 7 y's there. And z, take away 1 from the top, take away 1 from the bottom, leaving you with 2 z's on the bottom. Yes, for my z, I always put a little tail. That's your answer. Now, you don't need to put the 1 on the x, you can just leave the x, that's fine. It's the same thing. Any questions, comments, concerns? Okay, now, let me state something. If I had a negative here, does that change anything? Yeah. This is just a negative in the end. Negative signs like a -2 doesn't mean you move it. Powers, when you have a negative power, that's when you move it. Does that make sense? You can move it to the other side of the fraction bar. It's a common, like, quirky mistake that people make. They overthink the problem. These are way easier than you think. They're way simple. Okay? Like the problems I'm giving you right now are way more difficult than the problems you're going to see in your book. This is way more difficult. There's way too many letters compared to what I'm going to give you. Don't get me wrong, there's going to be a few that have a few letters, but the majority of them are just easy, simple things right now. Okay, any questions? Now, let's talk about this fraction rule. You can do that same cancellation method. You can do that with numbers as well. It can work with numbers. So if I gave you 3 to the 2nd, 3 to the 5th, you can still do the same rule of canceling with numbers. So like, you notice that they both have 3's. This one has 2, that one has 5. I can take away 2 of them and take away 2 down here, so leaving you with 3 3's down there. Does that make sense? You can do that with numbers, not just letters. It's the same thing. How you know to do that? Do they have the same base? Yeah, they have the same bases. The bases were the big 3's. So that's why I know I can cancel them out and stuff. That's how the letters work. The bases are the same. So I can cancel whatever one's the smaller one out. Okay. Questions, comments? Okay, alright, let's move on to the next type. The next type is where we have negative powers. So we've talked about the product rule, talked about quotient, powers of powers, we'll get to that. That's going to be one of the ones where I mix it all together. But let's talk about negatives first. Let's talk about negatives. So on this particular problem, it's just kind of random. What are the items that have negative powers on them?
X's and right down the bottom.
Yeah, the x's, both of them do, and then the y on the bottom. Those are the only objects you're going to move. The 2 and the 5 are going to stay there. They don't have any negative powers on them. I didn't even care if that was a -2 like I did earlier. That's a -2. Doesn't matter. It's going to stay there. Okay? It's only when you have negative powers that object will move to the other side of the bar. That's what I would do. And I would move those first before anything else. Don't start canceling stuff and crossing things out. People lose track. Move things first. Get everything positive again. And then we can deal with canceling. So the 2 and the 5, yeah, they're going to stay. Alright. Let's deal with the x's first. That x will go to the bottom. This x will go to the top. Okay. This y will go up. That y to the third's already up there, but this y is going to join it. So there's y to the 1 going up. Z to the first stays up there, and that z to the fourth is going to stay on the bottom. Any questions right now of how I moved things? Question? Please.
Why don't they combine the y to the third and the y to the first?
We will.
Oh.
We will. Yeah. Great question. Why wouldn't we combine? Not there yet. I'll start canceling stuff and combining stuff here in a minute. Yeah, good questions. If you wish to combine things right away, do it. I don't mind. I'm just showing you what's happening, moving things around. Yeah, great question. Any other questions? Okay, that was good. All right, so let's talk about the x's now and the y's, and we'll start combining and crossing things out and all that good stuff. So, for instance, Cassie, she just asked about the y's. Combine it. Okay, combine it. The 3 and the 1 makes 4. You can do that. I'm going to start canceling stuff and combining stuff in 1. So if it gets too much, just let me know. So right now, I'm going to cross out the 2 x's. Get rid of the 4 here, making that 2. Because I'm going to get rid of 2 off the bottom, so I have to take away 2 from there. The y's, these are going to combine to make 4, for sure. So far, this is what we have. Well, there's 2 x's left on the top. There's 4 y's up there, because they're not going to cancel anywhere. And then what about the z's? Yeah, because you're going to take away 1 from the top, you have to take away 1 from the bottom. And that means there's 3 z's left over. That's your answer. That's how you do that problem. Okay, that's doing cancellation method by doing like extreme shortcuts. That's how you do it. I've definitely seen this taught differently. I don't even want to even show you what I've learned about, so it would just confuse me more. So, does this make sense to you? If it doesn't, let me know, because then I can show you a different way to do it, because I do have multiple ways. Okay, now, that was negative powers. Now, the problem is, we're going to combine all of this. We're going to make this bigger. We're going to put, you know, parentheses, and we're going to put fractions. We'll have negatives in there. But I'm going to make it all into one kind of a thing. So here we go. Now comes the difficult problem. Whoa. Yeah, look at this. We have parentheses and we have negatives. And whoa. There's a lot of stuff going on here. What I would do, personally, is I would distribute the powers first. Get rid of all the confusing parenthesis idea. So I would, you know, okay. I would distribute the 4. I would distribute the negative 4. Distribute this 4 to that. Once you distribute, then I would, you know, multiply the top together. That's what I would do personally. Okay, and I'll show you kind of how that works. And then, at the very, very, very end, I would do what I did over there. Then, the last step, I move things around. I move negatives top, bottom, and I start crossing things out last. That's my personal thing. It's just so I'm always on the same path. I'm always like trying to get it down to single items on the top, single items on the bottom, no parentheses, and then I move stuff later. I know some people are like, well, why don't you just move that one parenthesis down? Yeah, but then I lose track and I don't know what to do with them all. I don't want to do that. So let's deal with distributing.
Testing,
Okay?
1, 2, 3.
Oh, that's good. You know, like that. I'm already over it. All right, so here we go. Okay, distribute the 4 to both here. Okay, now, when I put a 4th power on the negative 2, it's going to turn positive. It will turn positive. I'll deal with it here in a minute, but I'm just going to show you that will turn positive. So just be careful of that when you start trying to type it on a calculator. So that's negative 2 to the 4th power, x to the 12th, because I'm going to distribute that. That 4 goes on the 3. It actually multiplies, because you're distributing, and that means to multiply. Okay? And we're going to multiply that. I'm just going to put a dot here. I don't like parentheses. I'm going to distribute this negative 4 to everything here. So that's a 5 to the negative 4th, and a y to the 12th. Okay. Any questions on how I did that? How I multiplied those the powers on? Now, I can tell you right now, okay? Question?
Why wouldn't you move the parenthesis like the
Yeah, this whole thing to the bottom,
Yeah.
I can do that. And if you want to do that first, you can. I personally don't. I like to, like my little rule that I always do personally is I always move things last. Like I move negatives around last because they might cancel. So if like negatives cancel, they may move right back to where they were.
Now you're gonna move the y since it's positive.
No, this y is gonna stay there.
Okay,
So, because if I move this first, they would have moved right back again. So I kind of wasted steps by doing it. So just my little quirky thing that I do, I always move things last like that. So, but if you want to, do it because it's not wrong.
But wouldn't it mess it up because you'd move the y to the bottom? The y is not negative.
No, yeah, because you move this whole parenthesis down, and then this stays negative still. The only thing when you move it down, the only thing that would turn positive is the power on the outside.
Got it.
That's why I always say don't move things till last, because then you got to worry about that rule. But yeah, so yeah, if you didn't understand that, like this negative means you could technically move it to the bottom and it turned to a positive 4 for power, but everything in the parentheses would stay the same. It would stay a 5 and a y to the negative third if you moved it. Okay, question.
Would you move, at the end of this, would you move the 5, you would move the 5 and the negative 4 down?
Yeah, that would move to the bottom later.
Okay.
That'll be probably the next step that I'll be doing here in a minute. Because I'm almost done. I'm almost to like a single item now. Yep. Down here, distributing, we got this 4 has to go through this parenthesis here. And so this is going to be big. That's what, 6 to the 4th, x to the 8th, y to the 12th. That's big. 6 to the 4th is a big number. It's 36 times 36. Big. Okay. Any questions? Okay. So now, at this point, if you had negative items, if I have negative items, because notice, do I have any parentheses anymore? No. Now, I know there's a dot here, but there's no parentheses. I'm done with distributing everything, so I'm not worried about that. I'll move the negative items now.
Testing, 1, 2, 3.
Okay. So this item here is pretty much the only thing that moves. So do you see how that I save time by not moving things first? I'm only moving one item now, not 3 or 4 of them. So that 5 to the 4th will move to the bottom. So here's what we have so far. We have the negative 2 to the 4th. We have the x to the 12th. We have that y to the 12th. And on the bottom now, the 5 to the negative 4th moved down. So that's going to be out front now. There's the 6 to the 4th that's down there. I have an x to the 8th and a y to the 12th. Now, I can tell you, 5 to the 4th, that's a big number. It's 25 times 25, it's like 625. 6 to the 4th is 36 times 36. It's literally like 4 6s being written out and multiplied together. I don't know what 36 times 36 is. It's got to be big.
1,296.
Jeez. Okay, it's big. So those are going to be some crazy numbers. Anytime you go with 4s, your numbers are going to get big. They're going to get big quick. Okay, and then this number up here, this is the one that you need to worry about. Putting in negative 2 to the 4th power. That should be positive. Yeah, that should be a positive 16. And if you type it like that, your calculator won't tell you that. It'll tell you negative. It's technically a 2, negative 2 in parentheses with a 4 on it. Because that's the number I distributed the 4 to. So, yeah, so the top here, that's a 16, x to the 12, y to the 12th. On the bottom, this is a 625. Is that 5 to the 4th? Is that right? Somebody double check me. 5 to the 4th. Is it 625? Okay. And then, Jackie, what was that number you said earlier for the 6 to the 4th?
1,296.
96. Okay. And then x to the 8th, y to the 12th. Right. And I'll still have to multiply those two big numbers together. And now at this point, those two numbers here can multiply together. You get a crazy number of 16, and then I can start canceling stuff out. Okay. I'm not going to worry about the numbers right now. I know that you guys can type these in at some point. But what about the x's?
Lose 4 on the bottom.
Yeah. If I take away the 8 x's from the bottom, there's only 4 left up here. The y's, what happens to the y's?
They all go away.
They're gone. There's exactly the same amount. They literally cancel each other out because y to the 12th over y to the 12th is the number 1. It divides out. So those are gone. So all we have to deal with now is these crazy numbers. And I know for a fact they have to have, you know, whatever you multiply this out, it has to have a 16 on the bottom. There has to be a 16 down there. 12 or 1,296 has a 16 in it. It's guaranteed. There's a lot of 2's and 6's. Okay. So it's 1,296 divided by 16. It's just 3 times 3 times 3 times 3. So it's 9 times 9. It's 81. So so you have a 1x to the 4th, and then you have 81 times 625, which is
810,000 is your, right?
800.
No, it'd be 50,065.
Oh, yeah, sorry.
50,625.
Yeah.
And there's no letters on the
That's
bottom.
the last thing. Sorry. That's
Okay.
actually good.
Okay, questions.
That's actually
The
good.
big numbers on the bottom being multiplied together. Okay, the big numbers. So this is going to be like that ridiculous number that you were saying, right?
That's and then you divide by
This
16.
is huge. And then they both, like this 16, this big number had a 16 coming, so divide them both by 16. So 16 divided by 16 is 1. The big, stupid number divided by 16 is that thing. Correct? Okay, makes sense now? I saw the hand look. Alright, any other questions? Okay. I made that problem up. That's ridiculous. You won't have a problem with that, guaranteed. I made it up because I want to over-prepare you. When you get to your homework, you're like, this is easy. Good Lord, why do you even show us that? You're over-prepared. If you can do that problem, or you can at least follow it, you can do the stupid problem that looks like this by itself. So, more than prepared. Okay, scientific notation. This is our last topic today. Scientific notation is how to take a number, like a big number or a small number, and rewrite it differently so that it's compact. It's smaller. It fits on a calculator screen. You know, I can't write, can you hold up that calculator? Okay, those calculators, they're fancy. They have a menu. I think you can write as many digits as you want. It just goes across the screen and keeps going. There's certain calculators you can't. There's these little, like, scientific ones that you just can't go very far. Let's see if I have one. Yeah, like this. It can only go like 8 digits. You know? So you got to make sure that you realize, like, sometimes the calculator will actually give you scientific notation so that it can actually display the number on the screen. And that's the part where you got to get used to how your calculator does it. Every calculator is differently. I can tell you how Texas Instruments do it. I can tell you how Casio's do it. But if you have like some weird off-brand that I've never heard of, you got to get used to how it displays it. So when it gives you that certain number, and the weird part is, can I see this calculator? These calculators are all different. So it'll choose to spit out scientific notation randomly. Like it's just like this calculator is programmed to do it at a certain time, like when there's maybe 4 decimal places. The Casio or the Texas Instruments, like that orange one, hold up to that. It might just spit it out when there's only 3 decimal places because it doesn't want to display all the decimals. It's really weird. I cannot pin it down like when they just decide to do it. So it's your personal calculator, it's your personal preference on how it looks. Okay, but the problem is, what we need to discuss right now is, what is it? What is scientific notation? Because some of you have probably not seen it yet. Some of you have, but you're just not quite sure how it works or why it's used. So let's talk about that. So I'm gonna start with 2 easy examples. So I'm gonna just do a big number, like a 7-digit number. So let's go with 9,562,000. Let's do that. Okay, big number, right? Most calculators can handle that just fine. I think even a cell phone can, you know, they can go a certain number of digits across the screen. So I think it just fixes the font so that it fits. Okay. All right. So if this is your problem, we can write it in scientific notation, what I call proper scientific notation. There's a difference. Scientific notation is shorthand. Proper is where you have to put the decimal in a very, very specific spot, and that's what I want. What I mean by scientific notation, I want you to take the decimal where it's at. Where's the decimal right now?
After 0.
Yeah, at the very end, right? That's typically where they are, unless they display it somewhere else. You need to move it behind the first number. The first number is the 9. move it all the way to the front and put it behind it. So 9.562. And chop off if there's a bunch of zeros. We don't need them. That's just unnecessary. If there's a bunch of numbers, keep writing. You can write the numbers out. Just you gotta move the decimal behind the first number that you see. So going to left or right. So I'm moving behind the 9. Now, what you're gonna do after it is you're gonna put a power 10, like times 10. Now you're probably wondering why 10? 10's, when you multiply by 10, all it does is it just moves decimal. That's all 10's do. When you multiply by 10. So right now, multiplying by 10, it would just move the decimal in one spot. That's all it would do. How many spots do I need to move the decimal to get it back here? 6 spots, right? Use the commas. There's 3 more, that's 6. This is scientific notation. It's the same number. It's just doing a shorthand of writing it. You can type this in your calculator with like, I don't know, 5 buttons, something like that. Because you type in 9.562, you hit the little scientific notation button, which for some calculators, it's a little EE on the screen. Some, I think on the Casios, they actually have like a times 10 button. That's kind of nice. So that's Casio's brand. They actually have like a patent on that. That's why Texas can't use that. But I think Texas Instruments use the little EE button. It's somewhere on your screen. It's usually down by the decimal point. Sometimes it's above. It's above the parentheses button. I don't know where it's at. It depends on your calculator. When you type that, then it's waiting for the power you're going to type. So if you type 6 and hit enter, sometimes it will just blank and it'll just do this again. Sometimes it will actually give you the top number. I don't know which one it will pick. The reason I'm showing you this is sometimes you're doing these crazy calculations and in the very end you hit enter and it spits out this. What is that number? It's 9 million. It's not 9, it's 9 million. That's why you need to understand, because I know there's people in the math test, you know, they're using the little calculator on the screen and you hit enter and you see the number, it's like 9, and you look down the list and oh, there's a 9, you pick it. But it's not 9 million, you just picked the number 9, because that was what your calculator displayed. So you gotta know what this actually means, so that you're actually giving me the right answer. I actually want the top one, right? That. Now, we can do it for decimals. Decimals, that's a really small decimal, right? Most calculators will not choose to display a number like that. They will not display that number. It'll do scientific notation. So the difference here is if you're on a decimal, like a number that's less than the number 1, like less than $1, right? That's way less than $1. It'll use negative powers. It's the only difference. That's how you know it's in scientific notation. So they'll put the decimal behind the first number on the left, so 3.41. They'll use a little times 10 button because they move the decimal over here. And then they'll just put a little negative power. That means you have a number that's less than $1. That's how you know it. So it's a decimal. So how many spots do they move it? 4 spots. That's your answer. That means the same thing. The negative just means it's less than $1. That's how I always remember. It's a decimal place. I'm not that person that goes, okay, you gotta move it to the left so many spots, or right so many spots. Stupid. Think about it. Positive powers are a big number. Negative powers are a really small number. That's how I remember it. Common sense. Okay. Any questions with that? What you're going to have to do on your homework is they're going to give you a number. They want you to write it into scientific notation. Okay? We'll go through a couple more examples tomorrow of what you can do with this. Okay?
Is there a certain amount of digits you want us around to? Like,
I think the book asks you to go like 2 or 3 decimal places. I don't care how many you write, because I'm going to have the entire number written out. So if you go 2 decimal places, I'll check it and I'll make sure it's right. Okay? If you want to write all the digits that you like, do it and I'll have it checked. Okay? Okay, we good with that? Okay, here's your homework today. I will give you a bunch of time tomorrow to work on it in class. If you're not here, sorry. But I want to make sure that you understand when we have homework. So let me write up here. Again, I bounced around a lot. A lot of these problems are pretty easy. So, okay, page 28. Okay, here we go. 14 through 22, the evens. Those are way easier than the ones I showed you today. They're just, multiply things together, simplify a fraction. There might be just 2 items, top and bottom. Where are they going to be left? 45 through 52 all. Okay, those are going to be a little more complicated, where they have parentheses. You have to multiply 2 bigger items together that have multiple letters on them. 55, 57, 61, okay? Those are the last few. Those are the ones where they have a fraction, and now you have powers to distribute over them. There's a few of them. And there's like 3 of them there. So you're gonna have to take your time on those. 57, 55, 57, 50, 61. Those are the ones that will take you the most time. It's guaranteed. And the last select few here. Let's see, we have 65 through 68. 80 through 86. Evens. These are the scientific notation problems. Are they going to give you a whole number? Or are they going to give you a decimal? And can you write it back to scientific notation? I'm going to stop there. Okay? Okay, so that's what you have. It's not bad. These are definitely easy. Till like you can go each problem like 1 second at a time because they just give you a number and you have to write it. So it's pretty straightforward. I didn't assign any crazy difficult problem. I think probably the hardest problem up there is probably number 61. Probably the harder one of all of them. So, okay, we understand what we're doing here today. Okay, video will be online tonight for today's class. We'll have audio and stuff, and it will sound good. That microphone sounds really good. Some practice runs. So, I think that's pretty much about it. Volleyball tonight. It's at 4 City. How'd JV football do last night? Was it a good game? Was it close?
Yeah, it was.
Yeah, they let it go.
Garrigan scored with like a last minute touchdown.
Alright.
And then we fumbled. Like we had a really good drive going, and then we fumbled with like.
So they at least looked at though.
Yeah.
Okay, that's good. That's promising. Alright. Football game this week is at home, I believe. Who do we face this week?
Alone.
Okay, so it's gonna be good. So, alright, there you go. Is there cross country tonight?
Yeah.
Where is that at?
Newman.
You know? Alright, good luck. That's out at the Mercy Center. Is that right? Yeah. I remember reading that. So, alright, there you go. It is the 30th. Yeah. I actually have the right date up today, not like yesterday. What do you got?
I'm potentially going to be gone a week in December, and
Okay.
I'm trying to convince my dad that this is going to be okay.
Okay.
But I know that I've got to get all my homework caught up, and the awesome thing about you is that you put your classes online, so I'll be able to watch.
Yeah. Okay, do you know kind of what week that is? Because that might be like,
December 9th or 16th.
okay, you're fine. Because I think like the week before Christmas is when we have our semester test. It's like that week of Christmas break.
I thought that they didn't tell me that before.
I usually do that, but if they give us permission, if not, then it's after. So
Yeah.
that's what I don't know. If they
I
give
know
us
that they did
permission.
it last
So,
year. I know that.
you'll have your practice test way in advance. I think I give out the practice test like that Thanksgiving, so you'll be fine. You'll have it way in advance. You can actually do that. So, and then whatever homework you'll see, don't have.
Yeah, awesome.
All right.
Thank
Yep,
you.
yep, yep.
It was one time.
So we're working on this stuff too.
Yeah, we're gonna work on it tomorrow. I'll go through a couple examples tomorrow and stuff, but just to make sure, like, if you have questions. Yeah.
Oh, for,
Yes, sir.
Decimal or fraction form.
Can you have a decimal and fraction for it? Yeah. Yeah. You can have a decimal on the top, some number on the bottom. Yeah. You could have them. Preferably no, but yeah, leave it there. We'll talk about. We're gonna.
Could it be decimal or fraction form? Like,
Oh, leave it a fraction.
say this fraction.
Leave it a fraction. If you have the choice.